So first, thanks everyone for attending the event. So I will give the first talk, in which case I will showcase Manta, which is first the vision, the current technical design, and also where are Manta going, right? So Manta is an on-chain privacy for Polkadot using zkSNARK. Before we get started, let me first briefly introduce myself. I'm co-founder at Manta Network and also assistant professor at UCSB. Just some fun fact with me, like related to crypto. I actually ran the first blockchain seminar at University of Washington back in 2017. I was an EX research scientist at Algorand. I was the author of PyTeal, one of the Algorand smart contract languages. My life choices kind of from Seattle to Boston and to Santa Barbara. Okay, let's get started, right? So why privacy, right? So this is basically the outsider's view of blockchain transactions, right? So you think blockchain is super cool, it's crypto, right? And then if I send the transactions to you on blockchain, because it's crypto, right? It must be encrypted and it must be private, right? It's kind of like a Neo sending a text message to Trinity, and everything is encrypted and super private, right? Well, it's kind of like this is like an elephant in the room, right? So if you actually understand the technology, it's not. Actually, this is far from the truth. So how does a blockchain actually work? It's not, kind of sending a matrix encrypted message to another. It actually sending a tweet. You are telling the entire world that your financial transaction happens. For example, if Alice wants to send 5 BTC to Bob, it's kind of like this transaction we're going to broadcast it like over the peer-to-peer network and literally to the entire world. Right, so this is what the kind of like a privacy situation in reality, right? And this is not good. So to show that how much need for privacy and how do people want privacy, so even before, actually at the beginning of the project, we did a survey, right? So our survey truly shows that privacy matters. So for example, right, more than 400 people actually participate in our survey. Ranging from people have been in the crypto space for a long time to someone just new to the crypto. And 80% of users have concerns about the linkage of their identity and their addresses, and which is a very reasonable concern, right? So if you want to do a bank transactions, you wouldn't leak your most valuable information, which is financial transaction, to the world. Also, this is fun data, right? More than 90% of users have inspect others' wallet addresses. And I have to say, I have done that too, right? Last but not least, more than 70% users have avoided and hesitated to make transactions because of this leakage of privacy. Right? I think this is truly a problem. And I think we all love DeFi. But at the end of the day, if we cannot solve the privacy problem for the users, right, I think this will dramatically limit the scope and the usage of DeFi. Right? So this is what we think. Right? I think we all love DeFi, but we do think the pre-fi is the future. So with that, so this is Manta's variant, right? So Manta's variant here is that we want to brought on-chain privacy for the Polkadot ecosystem and more. And before I kind of dive into the details, how does Manta work and what is Manta's product, it may helpful to look at what is Manta's position in the ecosystem and how does Manta as a project could empower the entire system and also other project, right? So this is kind of like this is a Polkadot ecosystem. We have a wide array of many cool projects. For example, like Akala, like A-Star, Moonbeam, and Fala. And please forgive me if I don't list your favorite project here, right? This is just an idea. And I think Manta as a kind of like a privacy providers, on-chain providers can create a great values to the ecosystem, and we have a great synergy with other projects, right? For example, so Manta plus Akala, which will create private stable coins, which is, everyone loves crypto, but there is a huge market for the stable coins, right? So the stable coins, you want to have your privacy when you transact stable coin. And also, for example, Manta with Fala. And in addition to, thanks to Fala's great TE mechanisms, it can do various things very efficiently. So Manta plus Fala will create an end-to-end private systems that you can empower many powerful e-commerce applications. Also, Manta as A-Star, we can, for example, privatize all the A-Star's assets, making sure you have the privacy guarantee while you transact A-Star assets. Last but not least, right? So Manta plus Moonbeam will give the opportunity to privatize ERC20 tokens, right? And like I said, there will be many more as the ecosystem of the Polkadot grows, right? So this is really the future of Manta, and hopefully be part of the future of the Polkadot, right? So this is the vision, but actually let me guide you to step by step to show you how should we reach to the visions, including what is our product, and what is our future steps, and how we are getting there, right? So as a team, we are firmly believer of a continuous delivery, right? We want to have a big vision, but we also want to have some intermediate deliveries to the community and to our users. So the first piece of the puzzle is we call Manta 1.0, which is MantaPay, right? So MantaPay is a decentralized anonymous payment protocol. I want to introduce this first because payment is really the foundational layer, right? If you don't have a private payment, or AKA fungible token transfer system, you probably very hard to build anything else, right? This is really the base layer. So this is, the protocol itself is very complicated, but this is the high level ideas of the protocol, right? From the user's perspective, you could have your favorite public crypto tokens. For example, you maybe have DOT, maybe have KSM in Kusama, and maybe have some stable coins in Akala, right? So we don't care as long as it's relay chain tokens or a parachain asset. So of course, with a standard interface, we will support to mint your public tokens to the private tokens on Manta. Right? Let's say the token name is a coin, then it will become a PA coin. Right? After it becomes a private token in Manta, so you can transact. For example, you can send to another private token, and if you want to get back to your public tokens, you can reclaim. Right? You can reclaim this private token back. So our goal is that we are gradually rolling support for all the parachain and the relay chain assets we think that are valuable. For example, like DOT, AUSD, USDT, and BTC, and your favorite ones, of course, right? We are like a decentralized project. We would hear your voice and which kind of asset you want to support. So that's a very, very high level idea. But you might say, hey, like how does this work, right? This sounds magic. You can just like mint these public tokens to the private tokens. So this is a very high level picture, but this is like how private transfer works. So in a public blockchain, right? So each transaction could be viewed as a state transition function. Let's say the blockchain transit from one state to another. Let's say the transaction is Alex sends Bob 50 tokens, right? As this transaction getting broadcast among all the validators, and every single validator re-executes the transaction to confirm this transaction is valid, and then the blockchain moves to the next state, L2. So in Manta, it's very similar. The difference here is there are two differences. The first difference is that the both L1 and L2, which is the blockchain state, is encrypted, right? So, which means the blockchain state won't leak any kind of like user information. And secondly, because the L1 and L2 is encrypted, right? So the transaction itself is also encrypted. And instead of showing the plain text of the transaction, it will include a zero-knowledge proof, right? And this zero-knowledge proof, by its name, is zero-knowledge because since as a result, it didn't leak any information. It also, at the same time, could verify the transaction itself is valid. And now, instead of re-execute every single transactions, now the validators are actually validating the validity of the zero-knowledge proofs, right? By validating the zero-knowledge proofs, the validators can be confirmed that this transaction is valid. And I know this sounds really magic, but I mean, actually, thanks to the many years of crypto research, now we finally can do this, right? So you might say, hey, like, can I know a little bit deeper, like, about the magic, right? How does this kind of like a zero-knowledge proof magic happens, right? Again, let me give you a very high-level overview of zkSNARKs, right? So you might see a lot of kind of like articles talking about zkSNARK and zero-knowledge proofs. So here, what I tell you is from the very high-level point of view, right? It's not that hard. It's actually very simple. So here is how I view the zero-knowledge proof and zkSNARK. All right, first you have a function, right? Let's say, take your favorite function, and here, one cool part is that this function can be in MP. I mean, this is kind of like computer science jargon, but what really means is that basically any function, right? Let's say you have any function that take input X and produce Y, right? And here is what zkSNARK do, right? We get back to our favorite Bob. So let's say Alice is a party and Bob is another party, right? So Alice want to prove, Bob want to prove to Alice fx equals to y, right? Also, without leaking the information about x and y. So for example, Bob want to prove to Alice, like, I love you, right? What can I do? So basically the zero-knowledge proof systems are going to the following process. The first thing they do is that they run a process called a public parameter generation. Essentially, they generate a pair of keys. Here, this is a P key, means a proving key, and a V key means verification key. Right? Basically, to sample some randomness together. Right. The next thing is that Bob runs a prover. The prover takes the proving key and also the input and also the computation. And now it will generate a commitment of X and commitment of Y and also the zero-knowledge proof. All right? And now, once you have the zero-knowledge proof and the commitment of X and the commitment of Y, Alice could easily verify the validity of the proof, which means the fact that Bob wants to prove to Alice where fx equals to y. And here, one thing you can see that from Alice's side, right, she doesn't even know x and y because she only knows commitment of x and commitment of y and the zero-knowledge proof, right? Basically, this means that both the input and the output to the function is hidden, right? So, I mean, this is super high level. I mean, of course, this is super high level idea of zkSNARK and zero-knowledge proof systems. But here is what we firmly believe, right? Like, we firmly believe zkSNARK is the future of the blockchain, right? And in terms of kind of the technology development, usually people say, hey, there is a so-called no free lunch theorem, right? There is no free lunch. You have to make trade-off. But I mean, zero-knowledge proof techniques is actually very rare. It's in the sense that it can check so many boxes at the same time. And also it's coming from the first principle. So we firmly think this is the future of the entire blockchain technology, right? So let me show you which kind of box that zero-knowledge proof checks. And the first, of course, is privacy, right? Privacy is important. So it's literally in its name, right? So it has a property so-called zero knowledge, right? Which means that the proof itself will not intuitively will not leak any informations about both input and output, right? The second property is actually efficiency. And this is something that not everyone knows, right? So efficiency, so this is a tricky topic, right? So efficiency means that no matter how big your computation is, the proof verification is very, very efficient. And more concretely, in Groth 16 is roughly about 7 to 10 milliseconds, given your normal computer, right? This is super, super powerful because, as a blockchain system, the validator's computation is very expensive. Why? Right? Because think of how many validators you need to validate the entire transactions. For example, I know in Polychain system, you roughly have 1,000 computers, right? Any computation cost you have in the validators, you need to times 1,000, right? And ZKP here is really a game changer here in the sense that no matter how big your computation is, the verifier computation is constant, right? And this is why ZK rollup are becoming popular, right? This is the ZK rollup exactly leverages the efficiency properties of zkSNARKs. Last but not least, and also it's kind of not, I would say, underexplored, is composability, right? So, composability is very, very important in any kind of like a blockchain product, right? So I think in the blockchain world, you want to compose one kind of application to another and create a better ecosystem. And zkSNARK is great for composability as well, right? And technically there are fancy ways of doing composition. For example, you can use a recursive SNARK, and there is even like a new crypto research called Lego SNARK. And you can use a simple way, right? Basically by sharing the commitment between the different ZKP statements, right? So allow me to spend a little bit of time here, but we truly think the zkSNARK is the future of the blockchain, right? So for example, in terms of Manta, right? Manta, we use a Groth 16 scheme with ArcWorks Rust implementation. Yes, we actually need a trusted setup, and we want the entire community join us in the trusted setup. So our prover is actually also very efficient, right? So we roughly need 7 seconds in our prototype benchmark for the prover time. And the verifier is roughly take 10 milliseconds in our prototype benchmark as well, right? We actually, during these 4 months, we actually reduce our circle size by 70%. And thanks to kind of like an aggressive like a design optimization in the ZKP designs, right? So this is MantaPay. And MantaPay is already, we finished the prototype. We're working very hard to come with a very, very good wallet protocol, so that I think by kind of a conservative estimation, our testnet with kind of like a full MantaPay features will be rolled out this month. And so that's the first product. Then the second product, we call it Manta 2.0, is MantaSwap. So Manta 1.0, you can privatize your favorite public tokens to private tokens, right? So one thing we observe is that just have a token transfer is not enough, right? So in a DeFi world, people want to exchange their tokens, right? So this is one of the literally most important application of DeFi. And so we want to support that as well, right? So in MantaSwap, right, it's kind of similar to the MantaPay, right? After you mint your favorite private tokens, you can exchange these private tokens to another private tokens, and with Manta guarantee your privacy, right? After you change the private tokens, you can transfer it again. You can reclaim back to the public tokens, right? So or participate or in your other kind of favorite DeFi activities. So how does MantaSwap work, right? So MantaSwap actually leverages a transaction, kind of like a swap mechanism called automatic market makers. So for the sake of time, I would not dive into super details in the automated market maker. So the idea, but the high level idea here is that instead of trading against a single person, right, you are trading against a curve, right? So each single point, these automated market makers, these two coins balances are, a position is 1 point in the curve. And once a trade happens, for example, you want to trade some like A coins exchange to B coins, the positions move in the curve, right? So I mean, there are many kind of AMM invariant, but for example, the famous invariant is called X times Y equal to K, right? So the whole idea here is that we actually using zkSNARK to making sure this AMM invariant is invalid during your transactions, right? So you might say, hey, like why use AMM, right? And although, I mean, you can literally see the most popular crypto exchanges are running AMM, right? Seems to need a little bit of justification, but let me still list the reasons like we think why AMM is super cool. So first is that AMM has a limited degrees of front-running resistance, right? With a right curve design. So secondly, and most importantly, right? So AMM actually achieves very, very high gas efficiency, which means that amount of computation that you needed to perform the AMM swap is very, very minimal. And this very fortunately to directly translate to ZKP efficiency, right? Which means a smaller secret size, faster transaction speed, and less gas fees. Last but not least, right? So AMM has a decent capital efficiency as well, right? So again, the very, very high level idea of how Manta works over AMM is that we actually embedded the AMM invariant to the zero-knowledge proofs that we're going to validate over Manta Networks, right? So that's so far about Manta 2.0. So our AMM ZKP prototype has already finished. So one thing I didn't put in the slide, but I want to emphasize here is that Manta's AMM is actually the first fully private AMM that not only guarantees traders' privacy, it also guarantees liquidity providers' privacy. So this is very, very important. We actually have an ongoing academic paper being in submission to Financial Crypto this year. So that's Manta 2.0, right? Last, I want to give a little bit of vision about where Manta is going and where is Manta 3.0. Right? The idea of Manta 3.0 is that we want to build a privacy-preserving smart contract platform. So if you look at the trajectory of Manta, right? So I would use an Amazon analogy, right? So Amazon actually starting from a bookstore. And once they get so much experience in building an online bookstore and online computing, so they move to AWS where they provide the computation of the resources to the broader world. I think I will say this is a kind of a similar trajectory of Manta, right? So Manta 1.0 and Manta 2.0 will, as a product, right, we provide a private token transfer and private swap. And as Manta 3.0 will become a platform. So the whole idea here is that as a product, right, we are very easy to use. But as a platforms, right, so I mean, ZKP is great, and the privacy is great, and blockchain is great, but there is a hidden cost. The hidden cost is the development cost, right? So, I mean, we are a ZKP expert, so we hope that we can bring our expertise to the broader community so that you, as a developer, you don't have to understand ZKP, right? Maybe you just need to understand from a high-level point of view, but we will do the hard work for you, and you can leverage our platforms. Right, so this is still kind of a little bit of vision, but this is basically what the Manta 3.0 as a platform going to look like. Right, first we want to implement some very efficient ZK friendly curves into Polkadot runtime, so that we get a better efficiency. And since we build MantaPay and MantaSwap, your favorite application contract, instead of creating such a complicated and high-tech payment and swap protocol by your own, you can directly leverage the MantaPay and MantaSwap as a library, right? So write your favorite application contract, for example, zk rollup, maybe some banking, loans, synthetic assets, and NFT in a very easy to develop programming language, and you can leverage our MantaPay and MantaSwap as a building blocks, and also some pre-built zero-knowledge proof gadget, right? And also we're going to provide SDK for the end users. So here, let me talk a little bit about the Manta 3.0 architecture goals, right? So these are the concrete architecture goals we want to achieve in Manta 3.0. First is that we want to removing trusted setup, and trusted setup is cool, but the problem is that each single time you want to update your application logic, you need a new trusted setup, right? So we want to remove trusted setup by using universal SNARKs. So I think there are a few candidates right now. We're looking at Plunk, Halo 2, and Marnie. So the second is that we want to have a semi-stateless design, right? So the idea here is that we want to separate consensus and storage using cryptographic accumulators that is ZK friendly, right? So we want to say, hey, so the idea here is that we want to separate consensus and storage. So there are dedicated runners are just for consensus, but there are other runners just need availability rather than security. And these runners just in charge of the availability and will be much cheaper and could open for the community to run. Last but not least, we want to have a programmer-friendly zkSNARK contract languages so that any people, for example, ideally familiar with Solidity development could actually write a zkSNARK contract. So that's kind of like Manta 3.0 vision here. So with that, let me show you a little bit about the Manta's progress. Right, last November 2020, we finished our cryptographic protocol design, and then we built a Manta 1.0 prototype, and we submit a Web3 Foundation grant, and it reached milestone in March. And from March to now, we are building a lot of. We're basically moving the product to the from the prototype to the product, right? We have done many things in terms of product development, and most importantly is the wallet protocol, right? And also in this September, we just started to Calamari Manta's Canary Networks crowd node, and we're also going to launch the testnet this September. And also, there are many more milestones incoming down the road of Manta 2.0 and Manta 3.0. Right? So with that, I will end the talk here. Also, just a brief advertisement here. Like, we're hiring. It's highly innovative system work with cross-discipline collaborations. And it's literally in the intersection of applied crypto, distributed system, and compilers. And we would love you to join us if you have that expertise. Right. With that, I will end the talk here.